Hello, looking at compound events today and trying to figure out what is the probability of different compound independent events. So, for example, spinners and dice mixed together. When we found the probability of compound events, we created a tree diagram. And a tree diagram is a great way to come up with the total number of outcomes and to be able to create a sample space. So then you can use a sample space to be able to get all the different possibilities and help you to calculate theoretical probability. So that was a lot of words. So here's tree diagram. The problem with the tree diagram is it can be get really large and be hard to manage. So we're going to look at another way to do two-event probability and list all the outcomes. So here's an example of a spinner where each of the wedges are equal size. And if you spin the spinner once, what is the probability of not getting an even number? Well, to spin it once, you don't really have to do anything special to find the probability. Just the denominator is the total number of possible outcomes, which are 5, and the numerator would be the number of things that are not even. So that would be 1, 2, 3 out of 5. So there are 3 not even numbers, or odd numbers, out of 5. So the probability is 3/5, or 60%. So that's easy. That's why it's called simple event, because it's very simple to find the probability. But in number 2, you're spinning the spinner twice. So that's going to make it a compound event. And sometimes we think if you're going to spin it twice, that means, well, there's 5 the first time, 5 the second time, so it's like 10. But that's not how that's not how it works. So what I'm going to do is I'm going to create a table that's going to have all the outcomes possible when you spin the spinner twice. Now I could have made a tree diagram, but I'm going to try a table this time. So on the left-hand side of the table is all the outcomes when you spin it one time. So the first time you spin it, here are all the outcomes. Just get a 1, 2, 3, 4, 5. Across the top of the table, I'm going to list all the things you can get the second time you spin. Then, kind of like I'm making a multiplication chart, in the center, these are all the outcomes. So this would be spin it, land on 1, and then 1 again. This is land on 1 the first time and land on 2 the second time. I'm going to use these outcomes. How many of them are there? There are 25 total outcomes. I'm going to use those to find this probability. What's the probability of getting an even number twice? So looking through here, where are all the outcomes when both numbers are even? Well, there aren't going to be any in this column because the first number, because this has 1 as the second number, and that's not even. So here's the first one, but how many of them are there? There are 4. There are 4 even. That's 4 out of how many total outcomes? Not 10, not 5 plus 5, but 25. Because there are 25 possible outcomes. So the answer would be 4/25, or 16%. So you can write that down. So now, instead of spinning the spinner twice, I'm going to spin this spinner and I'm going to roll a die. And here are the two probabilities we're going to calculate. What's the probability of getting yellow on the first one, and then rolling a 6? And the second one is, what's the probability that I'm going to spin an even number and roll an even number? So I'm going to create a table for this. So this one I suggest you make. Go ahead and make yourself draw a box and make a table. And on the left, put all the things you can get on the spinner, because you're going to spin the spinner first. And on the top, all the things you can get on the die. Notice how this time it goes out to 6, because there are 6 numbers on the dice. In the center, I'm going to write all the possible outcomes. So for example, this right here, 4, 3 represents getting 4 on the spinner and 3 on the die, or getting blue on the spinner and 3 on the die, depending on how I look at it. So what's the probability that I'm going to land on the yellow wedge, which is the 2, and then roll a 6? So I have to look through here. I have to scan through. Well, here's getting yellow, and I'm going to scan through and see how many are yellow and 6. Just 1. 1 out of 30. There are 30 possible outcomes if I spin this spinner and roll a die. because there's 5 on the spinner and 6 on the die. So now, out of the 30 total outcomes, how many of them are even, or both numbers are even? There are 6. So I look through my set of numbers and I find that there are 6 outcomes were even. So that means 6 out of 30, or the probability is 1/5. So now you already have your table created. I had to recreate mine. Now try answering these 2 questions. So what's the probability that I will spin and land on 5 and roll and also land on 5? So I'm looking for 5, 5 in my outcomes, and there's one of those. So that's 1/30. Now I'm looking for what's the probability I won't get 4 at all, not on the spinner and not on the die. So I need to eliminate all the possibilities where 4 is part of the answer, or part of the outcome. So that means everything in this row and everything in this column. I have to count what's left over. So there are 20 outcomes that do not have a 4 in them. And so that's 20 out of 30, or 2/3. So the probability of not getting a 4 at all will be 2/3. So now we have to look at a spinner that is not equally divided up. And so in this spinner, you notice that orange and yellow are smaller than the green, blue, and red. So the probability of getting a red will be 1/4, because 1/4 of the spinner is red. The probability of landing on yellow has to be less than the probability of landing on red, because it's smaller than red. And so in order to find that, I need to divide the spinner up into equal sized pieces. So let me divide it up so they're all the same size as yellow. So now how many do we have that are the same size as yellow? 8. So that means the probability of landing on yellow is 1/8. Half the probability of red. If we then are going to spin this spinner twice, then our probability gets very complicated. Because if I try to make a tree diagram or a chart, and if making the chart I only list the 5 colors, it's going to appear like all 5 colors are equally likely, but they're not, because red is twice as likely as yellow, and blue is twice as likely as orange, and green is twice as likely as yellow. So really, when I make my chart, I need to list it like this. There's the chart. I need to list red twice, because it's twice as big, and blue twice, because it's twice as big as yellow. So there's really 8 outcomes. 2 reds, 2 blues, 2 greens, an orange, and a yellow. And across the top, there's also 8 again, because when I spin it a second time, I have the same outcomes. So how many total outcomes does that? Well, it's not 16, it's actually 64, and there they are. And you notice that a lot of them are repeated, but it's important that you give them their own size, because this right here, you have a 1 in 64 chance of getting yellow twice. Red is way more likely than yellow because the red section's bigger. So you're more likely to land on red twice than you would be to land on yellow twice. Matter of fact, you're 4 times more likely to land on red twice. So that's why they have to have all these reds and all these blues. So now what's the probability of getting a red and then a blue? There are 4 outcomes that are red and blue. It's 4 out of 64. So that's 1/16. So the probability of getting red then blue is 1/16. The probability of getting yellow then blue, where are they? They're down there. Yellow then blue. Since yellow's smaller, there's only 2 of those. That's 2 out of 64, or 1/32. So whenever you involve the yellow wedge or the orange wedge, it's going to be less likely because that wedge is smaller. If you use this chart that I made, try to now find the probability of getting a red and a blue in any order, and try to find the probability of getting blue. I'll get you started with the red and blue. Here are all the outcomes with red and blue in them. So if the order doesn't matter. So now see if you can write the probability of getting a red and a blue, and what's the probability of getting blue, blue. And here's that chart again, and now see what's the probability of getting at least one red. So look for all the outcomes that have a red in them. I'll show them to you. They're all here. So what's the probability of getting at least one red? And then what's the probability of getting yellow, then yellow? Okay, then you can check your answers, and hopefully that helped with the spinners and making a chart and uneven spinners. Thanks.